Hello, welcome to the Self-Learning Podcast by Dr. Sushma Singh. Let us start discussion on Unit 17, Measures of Dispersion and Variability. In addition to the measure of central tendency, it is generally desirable to have a measure of dispersion of data. A measure of dispersion or a measure of variability, as it is sometimes called, is an indication of the clustering of measurements around the center of the distribution, or conversely, it is an indication of how variable the measurements are. Sanders held that you need to measure dispersion to evaluate the extent to which the average value depicts the data. Another reason for measuring dispersion is to find out the spread in order to improve or control the existing variations. Let us move to the first point, the range. The difference between the highest and the lowest measurements in a group of data is termed as range. If simple measurements are arranged in an increasing order of magnitude, as if the median were about to be determined, then sample range is equal to xn minus x1, where x1 and xn are the lowest and the highest values of the series respectively. The range is a relatively crude measure of dispersion, inasmuch as it does not take into account any measurement except the highest and the lowest. Furthermore, since it is unlikely that a sample will contain both the highest and the lowest values in the population, the sample range usually underestimates the population range. Therefore, it is a biased and insufficient estimator. Nonetheless, it is useful in some circumstances to present the sample range as an estimate, although a poor one, of the population range. Whenever the range is specific in reporting data, it is usually a good practice to report another measure of dispersion as well. The next is the mean deviation. It is clearly that no information is provided by the range about the distribution of the measurements in the middle. Since the mean is so useful in measure of central tendency, one might express dispersion in terms of deviations from the mean. The sum of all deviations from the mean will always be zero. Therefore, such a summation would be useless as a measure of dispersion. If on the other hand, the sum of absolute values of the deviation from the mean expresses dispersion about the mean, dividing this sum by total number yields a measure that is known as the mean deviation, or mean absolute deviation of the sample is obtained. Sample mean deviation is equal to sigma xi minus m divided by n, where m is the mean, xi are the scores, n is the total number of scores, and sigma is the sum, and the vertical line indicates the values are absolute, irrespective of sign. It is possible that two samples may have the same range, but not the mean deviation. Mean deviation can also be defined by using the sum of the absolute deviations from the median rather than from the mean. Let us move to the next point, the variance. Another method of eliminating the signs of deviations from the mean is to square the deviation. The sum of square of deviation from the mean is called the sum of squares. If all the observations are equal, then there is no variability and S square is equal to 0, and S square becomes increasingly large as the amount of variability or dispersion increases. Since S square is a mean sum of squares, it can never be a negative quantity. The variance expresses the same type of information as does the mean deviation, but it has certain important properties relative to probability and hypothesis testing that makes it distinctly superior. Thus, the mean deviation is very seldom encountered in social or biostatistical analysis. The variance has square units. If measurements are in grams, their variance will be in grams squared. Or if the measurements are in cubic centimeters, their variance will be in terms of cubic centimeters squared. Even though such squared units have no physical interpretations. Now let us move to the next point, the standard deviation. The standard deviation is the positive square root of the variance. Therefore, it has the same units as the original measurements. It can be calculated using the following formula. Standard deviation S is equal to V into simple variance. Now the next point is coefficient of variation. Ratio scales are useful in social science research when an investigator is interested in the variability of a sample on one characteristic as compared to another. The coefficient of variation is the percentage ratio of standard deviation to mean, and it is calculated using the following formula. Coefficient of variation is equal to standard deviation multiplied by 100 and divided by mean. It is a useful measure of dispersion when comparison of variability is being made between the variables of unequal magnitude and have different units of measurements, for example, height and weight. Now let us conclude the unit. After working out in Unit 16 how to measure the central tendency in one's data, in Unit 17 you acquired the skill of measuring dispersion of data, which indicates the clustering of measurements around the center of the distribution, or you may say that it is an indication of how variable the measurements are. You may agree with Sanders, who said that the range is an easy measure to work out and understand because it requires only one subtraction and it places stress on the extreme values. The mean absolute deviation, on the other hand, places equal weight to the deviation in every observation, and it is equally easy to work out and understand. The squaring of deviation in calculating standard deviation emphasizes the extreme values. The standard deviation is a more common measure of dispersion. The value of every observation in a series affects the value of this measure. A change in the value of any observation will generate a change in the standard deviation value. Relatively few extreme values can distort its value. The standard deviation is not possible to compute from an open-ended distribution. Finally, the coefficient of deviation is similar to the range as it is based on only two values, which identify the range of the middle 50% of the values. It is mostly used in the sets of skewed data and is possible to compute it in an open-ended distribution. Now let us wind up the session, and we have come to the end of the unit. Thank you very much for engaging yourself with the Self-Learning podcast.